Two brothers, identical twins, born on the same day. One of them steps onto a spaceship, accelerates to 86.6% of the speed of light, and heads for a star 10 light years away. By every clock on Earth, the round trip takes 20 years. The brother on Earth ages 2 decades. The brother on the ship ages 1. 10 years of his life gone. This isn't a thought experiment. It is exactly what the math of our universe dictates. One journey, and these twins are permanently biologically out of sync. But the 10-year age gap isn't the strange part. The strange part is the illusion. For the vast majority of the journey, each brother looks out into the void and sees the other brother aging slower. And according to the laws of physics, both of them are simultaneously correct. But when that ship lands, the illusion breaks, and only one of them is right. Locked in their separate worlds, each twin watches the other through the lens of special relativity. The brother on Earth checks his calendar, counting the years as they pass. The brother on the ship, racing outward at 86.6% of the speed of light, marks his own time with the steady tick of his wristwatch. Both are certain of one thing: the other's clock is running slow. This is not a trick or a misunderstanding. It is the direct result of the Lorentz transformation, the mathematical backbone of Einstein's special relativity. At high speeds, time itself stretches and contracts depending on your point of view. For these twins, the effect is not subtle. The ship's speed means that by the numbers, each year on board matches 2 years on Earth. But from the ship's frame, it is the Earth that is rushing away, and the clocks back home that crawl. The symmetry is perfect. Both twins are in what physicists call inertial frames, constant straight-line motion, with no outside forces acting. Each measures the other's time as dilated, slower than their own. Each believes, with equal authority, that their own experience is the true passage of time. The mathematics does not play favorites. The Lorentz factor, gamma, in the equations treats both observers equally, no matter who is moving or who is at rest. No contradiction arises as long as the twins remain apart, moving at constant velocity. The illusion is complete, and the laws of physics guarantee that both perspectives are valid. There is no preferred frame, no hidden bias in the equations. The universe allows both stories to be true, at least until the journey changes. The paradox is not in the math, but in the expectation that time should behave the same for everyone, everywhere. Here, relativity shows its power. Reality depends on your motion. The break in this symmetry, the moment when one twin turns around, holds the key to the real age gap. But for now, the illusion stands unbroken. Subscribe for the next chapter in the story of time and speed. At the instant the ship reverses course, symmetry that held the twin stories together shatters. The traveler, halfway to the star, and now 10 light years from home, flips direction at 86.6% of the speed of light. In that single moment, the geometry of spacetime delivers its verdict. Not through acceleration, but through the way simultaneity itself is redrawn. For the traveler, the line that once connected the present on Earth to the present on the ship abruptly pivots. Before the turnaround, the traveler's concept of Earth's present slices through the calendar at year 7. After the reversal, that same line leaps ahead to year 13. 6 years of Earth's history, birthdays, seasons, everything are swept forward in an instant, while the traveler's own clock barely budges. This is not a trick of perception, it is the direct result of the Lorentz transformation, the same mathematics that governs every global positioning system, satellite, and every particle accelerator on Earth. A physicist might say the relativity of simultaneity is the real engine behind the paradox. The traveler's world line kinks, and with it the definition of now on Earth jumps ahead. No force, no rocket burn, no mysterious aging during a jolt, just the geometry of space-time, rearranged by a change in direction. The numbers are exact. The Earth twin's clock jumps from year 7 to year 13 as seen by the traveler, a 6-year leap written into the equations themselves. 3 independent frameworks confirm the result. The Lorentz transformation spells out the simultaneity jump. The so-called baton pass model, with a relay observer taking over at the turnaround, gives the same answer, and the Doppler signal counting method, counting radio ticks sent between the twins, matches the calculation to the tick. Each approach, grounded in the geometry of special relativity, agrees without exception. This is not an academic curiosity. The same logic powers the global positioning system that guides every smartphone. Without a daily correction of 38 microseconds for relativity, navigation errors would stack up to 11 kilometers per day. Einstein's equations, written in 1905, predicted these effects decades before satellites existed. The twin paradox is not a philosophical puzzle. It is a consequence of geometry, confirmed every time you check your location. Soon we will push the numbers even further, exploring what happens when speeds approach the very edge of light itself. For more mind-bending journeys into the fabric of time, subscribe now. A direct test of the age gap comes from counting the radio signals exchanged between the twins. Each twin sends out steady, regular ticks, 1 per year by their own clock. But because of their high-speed separation and reunion, those ticks do not arrive at the same rate. The outbound journey produces a deep redshift. The traveling twin receives each tick from Earth only once every 3.73 years, a Doppler factor of 0.268. On the return, the effect flips. The signals from Earth now arrive in a rush, at a rate of 3 3/4 per year, Doppler factor 3.73, blue shifted by the same geometry that stretched them before. The numbers are exact, not approximations. Over the full round trip, the traveler counts exactly 10 ticks from his own clock, while the Earth twin logs 20. The math is unambiguous. The total number of signals matches the proper time aged by each twin, confirming the prediction down to the last tick. This is not a matter of interpretation. The Doppler count, derived from Bondi's K-calculus, matches the Lorentz equations and the geometric path through spacetime. No matter which twin keeps the log, the difference in aging is written into the very signals they exchange. The symmetry of time dilation is real, but the tick counts tell the final story. Imagine the journey not as a single traveler, but as a relay. Observer A stays on Earth, living through the full 20 years. Observer B rides the outbound leg, moving at 86.6% of the speed of light, and hands off to Observer C for the return. Each segment is pure straight-line motion, no acceleration, no mystery forces, just the unbroken rules of special relativity. B ages exactly 5 years on the way out. C, picking up at the turnaround, ages another 5 years coming home. Earth's clock, ticking in its own inertial frame, counts the entire 20 years without interruption. This relay construction slices the paradox into 2 clean comparisons. Each traveler, B and C, can match clocks with A directly during their own inertial stretches. The numbers are unyielding. B plus C age a total of 10 years, while A ages 20. No part of this calculation depends on what happens during the split-second turnaround. The age gap comes not from acceleration, but from the geometry of their paths through space-time. 3 frameworks, direct Lorentz transformation, the relay handoff, and the Doppler signal count, agree to the last tick. The outcome is not a matter of interpretation or approximation. It is a geometric fact, confirmed by every clock and every signal. The illusion of symmetry vanishes when the world lines are compared, and the real difference stands revealed. For the next leap, where velocity pushes even closer to light speed and time itself nearly freezes, subscribe now. The age gap between the twins is not a mystery of motion, but a calculation of geometry. In Einstein's language, the true measure of time for any traveler is the proper time, the length of their path through spacetime. The formula is simple and relentless. Tau equals the integral over the journey of the square root of 1 minus v squared over c squared integrated with respect to time. For the ship racing at 86.6% of the speed of light, the numbers speak with clarity. The traveler's path carves 10 years of proper time, while Earth's straight world line adds up to 20 years. No hidden forces, no mysterious effect from turning around. Just the geometry of their routes. This same calculus guides the satellites above our heads. Every GPS satellite carries an atomic clock, ticking relentlessly as it orbits Earth. But those clocks don't agree with clocks on the ground. Without correction, each satellite's clock would gain about 38 microseconds every day. That tiny drift, multiplied by the speed of light, would cause your GPS location to wander by nearly 11 kilometers per day. The engineers who built the system didn't guess. They applied Einstein's 1905 equations before the first satellite ever launched. One GPS engineer put it plainly: if we didn't correct for relativity, your phone would get you lost before lunchtime. The twin paradox is not a puzzle for philosophers, it's a fact of geometry, written into every navigation device and satellite in the sky. Subscribe for the next leap, where velocity nears the speed of light and time itself nearly stops. The twin paradox is no illusion. Every calculation, every framework, every 38 microsecond drift in GPS proves the geometry. At 86.6% of the speed of light, time splits, not from acceleration, but from how the universe stitches events together. This isn't theory, it's navigation. Next stop, even stranger frontiers. Subscribe for the journey ahead.